In today's video, we're going to be doing exam type questions for Euclidean geometry. So without wasting any time, let's get straight into it. Question 7. 7.1 says complete the following statement so that it's true. The line drawn from the midpoint of the one side of a triangle parallel to the second side. So basically, if you have a triangle, right? And then the line drawn from a midpoint of one side of a triangle. So you have a triangle, line is drawn from this midpoint over here, parallel to the second line. What does it do? It bisects the third side. So this is otherwise known as the converse midpoint theorem. So to complete your sentence or statement, you're going to say it bisects the other side. To bisect means it divides the side into two equal parts. So that's your easy one, Mark. Let's move on. Remember what I always tell you guys. Whenever you get a diagram and or a question statement, make sure that you analyze the question statement or the diagram before answering your questions. So on 7.2, we are told that ACS is a triangle that we can see. Okay, so what do we know about a triangle so far? The sum of the angles in a triangle are equal to 180 degrees. That's what we know about this triangle so far. Okay. P is a point on AS. Okay. R is a point on AC. R is a point on AC such that PSRQ is a parallelogram. So if R is a point such that this is a parallelogram, it means that this PS will be equal to QR and also parallel. And it also means that these two sides will be parallel to each other. PQ intersects PQ. PQ intersects AC at B, such that B is the midpoint of AR. B is the midpoint of AR. So that converse midpoint theorem here applies because we are told that B is the midpoint of AR. This means also because these two lines are parallel, B3 will be equal to R2 because these are corresponding angles. Q1 will also be equal to R2 because it's alternate angles. P2 will be equal to S2 because they are corresponding angles. And then what am I missing? We have this triangle over here, triangle QRC. Okay, this R3 here will be equal to the sum of Q1 and C1. The reason being it's exterior angles. Okay. And then if you have this angle over here, you have this angle over here, you can calculate Q2. Okay. This is on a straight line, you can calculate this one. Also, CR is equal to PS. Okay. And we also said QR will be equal to PS. This means that QR will be equal to CR. This means also that triangle QRC is an isosceles triangle, meaning Q1, angle Q1 and angle C1 are equal to angle R3. Okay. And then C1, where's C1? C1 is 50. And then that also means that Q1 is also 50. And then R3 is 100. BP is 60 millimeters. This means that RS is equal to 120, and that's because of the midpoint theorem. So far, so good. Let's get to answering 7.2.1. 7.2.1, it says calculate angle A. So when you are working with Euclidean geometry, the first thing you have to do is start by the angles that you are given or facts that you are given, and then work your way to the unknown. Okay. So far, because we've been told that these two lines are parallel, you can say that R3 is an alternate angle of A because they form a Z shape. For 5 marks, you have to figure out how you're going to convince the marker that number one, these angles are equal, and how you've calculated this. Now, from our analysis, we already have an idea of what is R3. So let's start with what we've been given. Let's calculate R3. The first thing we've been told is that CR is equal to PS. And we also know that PS is equal to QR because we've been told that PSQR is a parallelogram. And that was given. Now, CR is equal to QR because both of them are equal to PS. So this also means that triangle QRC is an isosceles triangle because both of the sides are equal. So what do we know about the sides or the base angles of an isosceles triangle? The base angles of an isosceles triangle are equal. So this means that Q1 is equal to C1. Base angles of an iso triangle. This also means that Q1 is equal to 50 degrees because C1 is equal to 50 degrees, and that was given. Now, we are going to say that R3 is equal to Q1 and C1. Why? It's the exterior angle of a triangle. So this means that R3 is equal to 100 because essentially it's 50 by 50. Please write it in full. It's 100 degrees. The only reason why I'm not showing the degree symbols here is because I'm limited by the number of symbols I have on this particular program, but please write the degree sign. Initially, I said that we can also say that angle A is equal to R3 because of alternate angles. So you're going to say side AS is equal to QR. And then you're going to say, because PS, I'm sure this is still on a straight line, right? PS is parallel to QR. That was given. Therefore, R3 is equal to angle A. Reason being it's alternate angles. And then you also have to write PS is parallel to QR. The one thing I want you guys to remember is with Euclidean geometry, you have to use visual cues. It's easier for you to remember the visual cues because if you highlight every angle that's been given according to the angle statement and according to the theory that you already know from grade 9 and what you've learned this year, right? If you are able to combine everything, you are able to use the visual cues also to remember the points that you need to add in order to get your missing side or your missing angle. I hope that makes sense. Now for 7.2.2, it says determine the length of QP. Now, BP was given as 60 millimeter, and then RS is 2 times BP. Why? Because it is the midpoint theorem. So this means that RS is equal to 120. Therefore, RS is equal to 120 millimeters. We are determining the length. Now, RS is also equal to QP. Why? Because they are parallel. So, because PSQR is a parallelogram. Therefore, the length of QP is equal to 120. And that's your easy 3 marks. Alright? Remember to mention here that it was given. Almost made a mistake. Yeah, but otherwise, that's how you're gonna say. Now let's move on to question 8. Okay. So exactly what we did on question 7, we're gonna apply the same principles to question 8. Question 8 says ABCD. ABCD is a parallelogram. This will mean that this side is parallel and equal, and then BC is also parallel to AD, parallel and equal. So we are done. So if you have that, what can we also say? We can say that C1 is equal to G1, alternate angles, and then B2 equals F3, alternate angles. You also can do the same here, E, D1, and then A2 is equal to H3. Now we are done with the parallelogram. EF, E and F, or E and F are points on A, B, and DC respectively, such that AE is equal to CF. So what can you see here? You can see that if these two sides are equal and these two sides are equal, then also we have this angle A being equal to angle C because it is the opposite side of a parallelogram. We have congruent triangles. So DE is produced to J, okay, and then CJ is drawn. Okay. BF is produced to K, and then AK is drawn. Sharp. Now prove that DJ is parallel to BK. So for parallel lines, in order for you to prove that certain lines are parallel, you have to either prove for 3 cases, either one of these 3 cases. Case number 1, alternate angles. Case number 2, corresponding angles. Case number 3, co-interior angles. So we can either prove co-interior angles or corresponding angles. So for corresponding angles, if these 2 lines are parallel, you have to tilt your paper a bit. It means that you have to prove that D1 is equal to F3. If you can prove that these 2 angles are equal, you can prove that DJ is parallel to BK. We know that AD is equal to BC. We know this because they are opposite sides of a parallelogram. That was given. We also know that AE is equal to FC. This was given. Now, we can also say that angle A is equal to angle C. Remember to write the postal fees on top of these letters if you're writing an exam. I can't do that because I'm limited again by the app that I'm using. And these are the opposite angles of a parallelogram. Therefore, we can say triangle AED is congruent. Congruent is 3 lines here to triangle BFC, and the reason being it's side angle side. Angle E3 is equal to angle F3. Reason being it's sides of congruent triangles. Right. And then you have to also say that E3 is equal to D1. Reason being alternate angles. And then you have to also say which lines are parallel. AB is parallel to DC. So D1 is equal to F3, angle F3. Reason being they both equal to E3. Therefore, line DJ will be parallel to BK because D1 and F3 are corresponding angles. So here's your 5 marks. So for 8.1.2, you have to prove that E1 is equal to F1. You're going to say angle E1 is equal to F3. Reason being they are vertically opposite angles. And then angle E3 is equal to angle F3, which is because they are congruent angles. So it's because AED, it's sides of congruent triangles. AED is equal to BFC. Now, F3 is also equal to F1 because these are vertically opposite angles. Therefore, F1 will be equal to E1 because they're both equal to F3 and E3. And then there you have your 4 marks.